Over the last year, the whole fight against aging has just taken some absolutely massive leaps forward. I mean, we're talking about things like AI designing rejuvenation therapies from scratch, and even, get this, using simple sound waves to extend life. So today we're going to dive into the breakthroughs that are really pushing the boundaries of what we thought was possible for human longevity.
I mean, it's the ultimate question, right? It's what drives billions in research, and let's be honest, it's captured our imagination for centuries. But here's the thing. It's not just science fiction anymore. The stuff we're about to cover, it's bringing us closer than ever to actual, real answers. So let's kick things off with how our very understanding of what aging even is changing.
Okay, first up, the way we even think about aging has completely evolved. For the longest time, we kind of saw it as this one single inevitable process. But now, the scientific map is being totally redrawn, and wow, is it getting a lot more detailed. Yeah, for years, the hallmarks of aging have been like the Bible for researchers in this field. You can just think of them as the official list of all the core things that go wrong in our bodies biologically as we get older. And this past year, guess what? That list got longer. The official count of the hallmarks of aging actually got updated, and it's now up to 14. I mean, that alone just goes to show you how fast our understanding is really getting. So, what are these two new additions? Well, the first one is changes to the extracellular matrix. Just think of that as the biological scaffolding or the mortar that holds all our cellular bricks together. When that starts to degrade, it's a huge problem for our tissues. And the second one? Psychosocial isolation. Now, this one might make you go, huh? But it's a huge deal. It's the scientific community formally recognizing that our social lives, our connections, our mental state, they are fundamentally biologically linked to how our bodies age. Okay, so with this new, deeper understanding, let's talk about how scientists are shifting gears. They're moving away from just defining aging and are now actively trying to reverse it, right down at the most fundamental level you can get, the cell itself.
And this gets us into the mind-blowing world of cellular reprogramming. This whole idea really kicked off with the famous Yamanaka factors. Those are the four proteins, OSKM, that could take a regular old adult cell, say a skin cell, and turn it back into a super powerful youthful stem cell. But now, the real cutting edge is what they call partial reprogramming. The goal? Make the cell younger, but without completely erasing what it's supposed to be.
So this brings up a really fascinating problem. See, as we get older, our cells can start to suffer from something called mesenchymal drift. The best way to think about it is like this. Imagine a violinist in an orchestra suddenly trying to play the tuba. The cell gets confused, it loses its identity, and it starts turning on genes that it absolutely should not be. And that kind of cellular chaos is exactly what these new reprogramming therapies are trying to fix. And believe me, the race is on. You've got companies like Outsource Labs, and they've shown their partial reprogramming method can actually reduce that identity-stealing mesenchymal drift. Then you have Shift Biosciences, who took a totally different route. They found a single gene that could do the job of that whole complex four-factor cocktail. And then there's Retro Biosciences. This is wild. They teamed up with OpenAI and used a custom AI to completely redesign the Yamanaka factors, making them a staggering 50 times more effective. Just incredible. All right, next up, we're going to switch from reprogramming good cells to evicting the bad guys, senescent cells. You've probably heard of these. They're often called zombie cells. And for good reason. They stop dividing like they should, but they refuse to die. They just hang around, spewing out inflammatory junk and causing damage everywhere. So what's the big problem with these zombie cells? Well, it's always been about targeting. How do you get rid of a cell you can't reliably find? To take them out, you have to find them first. And for years, I mean years, scientists have been hunting for that one perfect, unique marker that basically screams, hey, over here, I'm a senescent cell. But this year, we got a potential new tool for the toolbox, DNA aptamers. Okay, think of these like tiny little programmable keys made of DNA. They're designed to fit one very specific lock. And in this case, that lock is a protein they found on senescent cells. It's a really promising step forward for sure, but the researchers themselves are being super cautious. The worry is that this key might not only open the zombie cell door, it might also fit a more general old tissue door. So yeah, the hunt for that perfect exclusive target is still on. But there are other ways to tackle this. We're definitely coming at it from multiple angles. For example, there's this super high-tech approach called CAR T-cell therapy, which was actually borrowed from cancer treatments. It's like turning a patient's own immune cells into heat-seeking missiles programmed to hunt down and destroy these zombie cells.
And just this year, we saw this method actually work to reverse signs of aging in naturally aged animals. That's a huge step.
But what if the answer wasn't some super complex, expensive therapy? What if it was something as simple as sound waves? And this is where science just gets wonderfully weird, and I love it. Researchers literally put mice into what you could call a tiny bathtub and then blasted them with low-frequency ultrasound. The results? They were just astounding. It actually seemed to rejuvenate their senescent cells. And get this, the mice that got this sound wave treatment lived longer. No drugs, no gene therapy, just sound. It's still early days, of course, but the potential here is just, wow, it's fascinating. Which, of course, brings us to the holy grail of all this research, right? It's not just about aging healthier. It's about living a longer, healthier life. So what did the past year teach us about actually, extending lifespan? Well, let's start with the Interventions Testing Program, or ITP. This is the absolute gold standard for testing this stuff in mice. It's a massive, super rigorous effort. And frankly, this year's results were a bit of a reality check, a reminder of just how hard this is. They found some compounds that gave a modest survival boost, but the effects were almost only in the male mice. This really shines a spotlight on a huge challenge in the field. Males and females just age differently, and it's complicated. There's no magic one-size-fits-all pill here. But then there was this study, and it was a real standout. It was all about elastin. That's the protein that keeps our skin and tissues all nice and springy. The problem is, as we get older, elastin breaks down into these little fragments, and those fragments can kick off a nasty immune response. Well, this research showed that if you block those fragments from doing their dirty work, you can significantly extend mouse lifespan. And even better, when they combine that approach with the famous longevity drug rapamycin, the effect was even bigger. Now that is exciting. So all of this is really pointing to one huge critical idea. A cell doesn't live in a bubble. The environment around our cells, whether that's right there in our tissues or system-wide in our blood, is just profoundly important. Maybe it's everything. And there is this one beautiful, elegant experiment that just drove this point home. Researchers took heart tissue from both old and young mice, and they washed all the cells away, leaving just the structural environment, the scaffolding, right? Then they did a switcheroo. They put old cells onto the young scaffolding and young cells onto the old one. The result? It was crystal clear. The environment was in charge. The old cells started acting younger, and the young cells started acting older. Amazing. So, taking that idea to people, this principle was actually tested in the very first clinical trial of therapeutic plasma exchange for aging. Basically, they take out some of a person's blood plasma and replace it with donor plasma and albumin. And the results were, well, they were striking. After just 1 month, the group that got the treatment saw their biological age go down by an average of 2.6 years, 2.5 years younger, biologically, in a month. Okay, and for our final breakthrough, this is something that feels like it's been ripped straight from a sci-fi movie. It's the tool that's about to put every single area of research we just talked about into hyperdrive. I'm talking about artificial intelligence. Just take making therapeutic antibodies, for example. The old way, it's slow, it's super expensive, it involves immunizing animals and then screening thousands and thousands of cells. It's a slog. The AI way, you literally just tell the AI what you want to target, and it designs a perfectly functional antibody for you, from scratch. It's instantaneous, it's efficient, it's cheap. This isn't just a small step up. It is a complete, total game changer for how we develop new therapies. So when you think about it, we've gone from redefining what aging even is to literally rewriting cellular code, and now we're unleashing AI on the whole problem. The pace of discovery is just accelerating like nothing we've ever seen before. And it really leaves us with one thrilling question, right? As we look to the future, with all these incredible new tools in our hands, what amazing breakthrough are we going to be talking about next year?